Welcome. I'm Mrs. Rutchling, and this is Chapter 6, Molar Mass. The molar mass is simply that, the mass of 1 mole, and it is always in grams. The unit is always how many grams per 1 mole. The nice thing is, it's equal to the numerical value of the average atomic mass, which recall is on the periodic table. Most of them on the periodic table are rounded to the hundredths place, and so that's what we will round to, except for hydrogen because it is so small that we have to include the thousandths place. For example, if I have 1 mole of carbon atoms and I would measure it, it would be 12 grams. So the molar mass of carbon is 12 grams per mole. I can do the same thing with silver. It is 107.9 grams per mole. And sulfur is 32.00 grams per mole. How is that related to molar mass and the average atomic mass? If I look, the value is the same. If I look on the periodic table and I look up the average atomic mass of 1 atom of krypton, it is 83.80 AMUs. The molar mass, so 6.02 times 10 to the 23rd atoms of krypton, is the same value, but the unit has changed. So for those who might be interested, this is how you would calculate from AMU to grams. But you don't need to, because all you need to do is look at the periodic table. If you're talking about 1 atom, the unit is AMU. If you're talking about a mole, the unit is grams, because we have grams per mole. Look on the periodic table and find the molar mass of these 2 atoms. When you look up bromine, you find that it is 79.9 grams per mole, and you must have this unit. If we look at tin, it is 118.71 grams per mole. The molar mass, and that's what I will refer to it, can be used to refer to the mass of elements, which some people call gram atomic mass, the gram formula mass or formula weight, which is ionic compounds, and gram molecular mass or molecular weight, which is used for molecular compounds. Instead of being this specific, I will refer to all of these as the molar mass. If I'm looking at molecules and compounds, I have to add up the average atomic masses to get the average atomic mass of the compound. I do the same thing for molar masses. So if I look at sulfur trioxide, I know that I have 1 sulfur atom and 3 oxygen atoms. If I'm looking at the average atomic mass, I can add those up, the AMUs, 32.06, 16, 16, and 16, and I get a value of 80.6 AMUs. If I'm looking at a mole of the sulfur trioxide, I use the grams per mole, but I use the same values, 32.06, and then the 3 oxygen. The numeric value is the same. The only difference is the unit. Let's give barium nitrate a try. If we look at that, we know we have 1 atom of barium. Recall that we distribute this 2 because it means we have 2 of the nitrate. So I have 2 atoms of nitrate and 6 atoms of oxygen. So now I'm going to look at the atomic weight, or I can call it molar mass now, and I want to multiply each of those. I take the molar mass and multiply it by the value of each number, and then I add all of those together. Recall we have to use the grams per mole unit. Notice my value is the same that's here on the balance. Pause the video and give these 2 a try. If we want the molar mass of potassium oxide, first we have to write the formula. So remember that we are going to take potassium, which is 1 plus, and oxide, which is 2 minus, and we're going to cross to get our formula. We know we have 2 potassium and 1 oxide going to the periodic table. We find the masses, and we come up with an answer of 94.20 grams per mole. We want to do the same thing with aluminum hydroxide. So first we have to write the formula. We know aluminum is 3 plus, and hydroxide is 1 negative. We're going to cross. Remember that when we have more than 1 polyatomic ion, we are going to put it in parentheses to show that there are 3 of the total. So I have 3 of the hydroxides around my aluminum. or I can just look at my formula and figure out, and my final answer is 78.00 grams per mole. When we calculate these, we are going to round to the hundredths place because most of our values will be 4 sig figs or to the hundredths place. Pause the video and give these examples a try. Check your answers against mine. Molar mass is the mass of 1 mole of whatever it is you're looking at, and it is measured always in grams per mole. The average atomic mass on the periodic table is the same numeric value as the molar mass. The difference is that the average atomic mass is 1 particle and molar mass is 1 mole of those particles.